we are going to look at classifying conic sections. Now, an equation of any conic can be written as this ax squared plus bxy plus cy squared plus dx plus cy plus f equals 0. And if we're given an equation like that, it's not obvious whether we have a parabola, a circle, an ellipse, or a hyperbola. But we've got a way that we can figure out which type of conic we have before we proceed with trying to write it in standard form or graph it or do any of that type of stuff. And what we're going to use is we're going to use the discriminant. And it's the same formula in order to decide which type of conic section it is before we try to graph it or write it in standard form or anything like that. We need to look at the discriminant, which is the same formula as in our quadratic formula. So it's b squared minus 4ac. What you have to realize though is that the b comes from your xy term, the a comes from your x squared term, and the c comes from your y squared term. So essentially D, E, and F play no role in determining what type of conic section it is. Now our rules for our discriminant. If our discriminant is less than 0, meaning it's negative, and B is equal to 0, and A is equal to C, we have a circle. So all three of these conditions have to be met in order to be a circle. Now if our discriminant is negative and either B isn't equal to 0 or A is not equal to C, then we get the ellipse. So if we have a situation where we have a discriminant less than 0, we have to decide between a circle and an ellipse. And to be a circle, B has to be 0 and A has to be equal to C. Well, if one of those conditions isn't met, then you know you're going to have the ellipse as opposed to the circle. Now if our discriminant is equal to 0, you're going to have a parabola. And our last one, if our discriminant is greater than 0, you're going to have a hyperbola. So that's how we're going to tell what type of conic section we have. So here's our first example. It says classify the conic section with the given equation. We have 0 equals 2x squared plus y squared minus 4x minus 4. Now the first thing you have to realize is it does have to be equal to 0 in order to use the discriminant. The next thing we have to do is figure out what is b squared minus 4ac. Now remember, our b comes from the xy term. And as I look at my formula here, I don't have an xy term. So that must indicate that my b is equal to 0. Then my a comes from my x squared term. So in this case, my a is 2. My c comes from my y squared term. Well, since there's no number there, it's just assumed that it's a 1. So when I calculate this out, 0 squared is 0, minus 4 times 2 times 1 is 8, so I get negative 8. So that takes me down to my two options. My discriminant is less than 0. So that means I have two options. I could be a circle, or I could be an ellipse. We don't know which one it is. So now we have to go back and check that extra criteria. It told me that if B is equal to 0, which we had, and A is equal to C, we would have a circle. Well, as I look back here, B was equal to 0, so that part checked out. But A is not equal to C because my A was 2, my C was 1, so it failed that condition. Means it's not a circle, so we pick our other one. It's an ellipse. Okay, here's another one. Go ahead and pause the video and see what you come up with. I will give you a hint. You've got to take care of this negative 55 first because our equation has to be set equal to 0 before you can actually apply this discriminant stuff. Alright, hopefully you would have rewritten it as 9x squared minus y squared plus 54x plus 10y plus 55 is equal to 0. Then when you do your b squared minus 4ac, b comes from your xy term, so we don't have one. It is 0. Minus 4 times our a comes from our x squared term, so that would be a 9. And our c comes from our y squared term, which in this case is a negative 1. Well, when I multiply that out, I get 0 minus 4 times 9 times negative 1 gives me a negative 36. Well, minus a negative turns into plus a positive, so I get 36. So in this case, my discriminant ended up being greater than 0, which automatically leads me to a hyperbola. Okay, here's our next practice one. Let's go ahead and pause the video and see what you come up with for this one. Alright, on this one, the first thing you needed to do was move everything to one side. I chose to move the 2y and the 4, move them to the left using subtraction. Then I did my b squared minus 4ac. So b comes from your xy term, which happened to be 0 again. The a comes from your x squared term, so that was 4. The c comes from your y squared term, that was also 4. So I ended up getting 0 minus 4 times 4 times 4 gave me a negative 64. Well, that negative 64 is less than 0, so that leads me to the option of having a circle or having an ellipse. So then I went and I checked, was b equal to 0? That was a yes. And then was a equal to c? That was a yes. So that means I end up with a circle for this one. Now we need to look at how can we write these equations in standard form and graph them. This is an equation that we had from before, and it is an ellipse. So I know that I'm going to be trying to get to some quantity squared plus another quantity squared equals 1. Now the first thing I need to do is I only want x's and y's on this side of my equation. I'm going to move this 4 over to the other side, so I'm going to have 4 equals. Then I want my x values here to be next to each other. So I'm just going to rearrange them a little bit and put it as 2x squared minus 4x. So I've gotten those taken care of. And then I'm going to put my plus y squared here. Now, I need to get these into some quantity squared. And if you remember back to completing the square, that is how we're going to have to get these quantities squared. So our process for completing the square is we have to take care of this number attached to our squared term first because we don't want it there. So I'm going to pull that 2 out and set it out in front and write it as x squared minus 2x. Now I am only working with my x values right now, so we're going to kind of just keep tacking this y squared along. Okay, once I get to this point, now I can go through the process of completing the square. So I'm going to have 2 times the quantity, x squared minus 2x, and then this is where we put in plus a box, and then that y squared is still just going to hang out there. Now, since I have added something to the right side of my equation, I have to add the same amount to the left side of my equation. So now be careful here, because it's not just a box I've added. Since I have this 2 out in front, I've got to think about, well, if I distributed that 2 back out, I would have 2 box. So I'm going to have 4 from up here plus 2 box. Now, in order to find what goes in the box, I have to take half of my b term here, which would be negative 1, and I have to square that, which would be a positive 1. And that's the number that goes in my box. Now, when I rewrite this, I'm going to factor this expression right here, this x squared minus 2x plus 1. And that's going to factor into x minus 1 squared. This number that we find right here is always what's going to go in here. And on this other side, I can simplify that all the way down to 6. So here's a new equation I've gotten. And I'm getting closer to having it in standard form because I've got my x quantity squared. Now on this one, I'm actually kind of lucky because I don't have any single y terms. So I don't have to complete the square for my y's. But if I had, like a plus 3y, I would have to go through the process now with my y's of completing the square. So for this one we got lucky because the y squared is all by itself, so it's already complete. Now the last thing, our ellipse has got to be set equal to 1. We have it equal to 6 right now. I need to change that into a 1 by dividing everything by 6. So I'm going to end up with 1 is equal. Now my 2 and my 6 will reduce to a 1 and to a 3. So I would have x minus 1 squared over 3 plus y squared over 6. And here we have our equation now in standard form. We've got the x quantity squared, we've got a y quantity squared, and we have it set equal to 1. Once we get our equation, now we just follow our regular graphing rules. So find your h's, your k's, your a, b's, your c's, and then find your important points and get those listed. So go ahead and pause the video and find all those values and your important points, and then we'll go ahead and graph it. Okay, the first thing I did here was I looked at my equation that I had and I decided which formula I had. Now remember, with an ellipse, your a squared is always bigger. So I knew that a squared had to be equal to my 6. Now that was also attached to the y, so that told me that I was using the bottom equation. I then solved my a squared equals 6, so I got a to be the square root of 6. I knew b squared had to be equal to 3, so b had to be equal to the square root of 3. I knew my h was the opposite there, so I had a 1. And my k had to be 0 because there was nothing being added to my y. So that gave me a, b, h, and k. Then the last thing I had to find was c. And I had that formula written down that c squared is equal to a squared minus b squared. So I ended up with c squared equals 3. C ended up being the square root of 3. Then I filled in the formulas from my flip book to find my center, my vertices, my co-vertices, and my foci. I plotted all of those points on my graph and then sketched in my ellipse. So once you get your equation written in standard form, you follow the exact same rules that we have been doing for graphing these. The tricky part is getting it into the standard form first. Okay, now this process here to write this in standard form works for circles, ellipses, and hyperbolas. We always keep the x's and the y's on the same side and then complete the square, sometimes once, sometimes twice, depending on our equation. Now with parabolas, to be in standard form, it's slightly different. We want our x's and our y's to be on opposite sides. So you would want to isolate that squared variable and complete the square only for the squared ones. So if we had like x squared plus 5x equals 10y plus 2, we would only complete the square for this side because it's the only one that has a square. This stuff over here doesn't have a square, so you would only complete the square for this side if this were our parabola. So make sure you first identify what you have and then go through the process of completing the square in order to get it written in standard form. Find your h, your k's, your a, b's, and c's, and then you can graph it just like normal.